I'm glad to be here, and Brian and I got to spend the day. Brian Woodward, co-maintainer of Assemble, is also with me. He's going to come up and answer some questions with me in a little bit. And we truly are 50-50 contributors to Assemble. But got a chance to spend some time in the city today, and it's really, really nice city here. So glad to be here. Need to make sure I keep this thing on. But we're excited to talk about Assemble because we actually built Assemble for more than just static site generation, even though generally the way we kind of promote it, or rather talk about it in all of the language that we have on our site, is always about static sites. And the reason is we initially had things about component generation and building a lot of component-oriented language, and nobody seemed to pay attention to that at all. And we noticed some people started coming onto our project and actually saying, we use this for static site generation, you should put that in your material because that's what our coworkers use it for and things like that. And so we were like, really? Started looking it up on Google and realizing that's what everybody was using it for. So, if it walks like a duck and talks like a duck. So we started, paying more attention to that. But before I dive into the actual talk and start going through the details of how Assemble works on screen, I want to tell you a little bit about the background of why we came up with it and what it does for us. Does anybody here work in an environment where you have you work with designers and developers both, and you have to throw things over the wall one way or the other? Yeah? A few people? Okay. So in our experience, we had design, and we were doing web pages, and generally the designers had vision of what they wanted to show up on the screen ultimately, and those things would get handed off or thrown over the wall to the developers, and so we had designer vision kind of up against developer implementation, and it wasn't 100% full cycle, because oftentimes the designs would go over in kind of a full page where a designer's putting a complete vision together, handing it over, and then developers are, at least in our environment, were cutting those up into partials and things like that, making the code reusable in the way it needed to be on the back end. And that tends to be a cycle that repeats itself. Another way to put it is that the developers could break the designer's designs, but the designers couldn't break the developer's code. So the feedback loop wasn't complete. And we wanted a scenario where there was no bottleneck between developers and designers. So we wanted to be able to come up with any design that we wanted to on the front end and just design it, but also use practices that would immediately be compatible with what was being used on the back end. So a designer would make things in components, build those into full pages, and have a similar experience anyway to what the developers are using, so that when the developers took that code, there was none or very little retooling or repurposing or recutting up of HTML or CSS or whatever. So that was the impetus, the beginning. So what is Assemble if it's not a static site generator? Well, we think of it as a build system that lets us do rapid prototyping. Really just make cool stuff and iterate as quickly as possible without having to worry about whether or not there are going to be implementation issues on either side of the fence. For example, here's some things that projects are using Assemble for today. There's an awesome style guide that is used for the Monterey Bay Aquarium, and here's what that looks like. And as you can see over on the left, obviously lots of categories that allow you to just flip through here in your own time, and if you're interested in this kind of thing. But Assemble makes that kind of thing easy, the categorization and the splitting up of things. And then I'll give you an example before I go any further that I didn't think of before. But this markdown file here, single markdown file, is the same file that is split up into slides that I'm going to be using as I continue talking. But so during one build process, Assemble takes those slides and assembles them into cut up HTML files with designs, but it also grabs them and throws them into a markdown file so that we can read it as notes. But it makes that kind of thing really easy to take templates or data and just mash them up however you need it to be and make it reusable. Another thing that Assemble is being used for is creating books. We've had a few authors tell us that they've actually written their book in Markdown and use Assemble to build the pages and chapters and things like that, because Assemble, again, makes it easy to organize things. So, and oftentimes for books, they'll use YAML front matter in the pages. I don't know if everybody's familiar with that, but it's just a section at the top of a Markdown or HTML file or Handlebars file that is sectioned off. It's fenced off, so to speak. And when Assemble reads through the files, I'll show this in a minute, but Assemble reads through the files, it strips out that section of metadata, and it turns it into usable JSON, is passed to the templates as context. In any case, for things like books and stuff like that, it's a convenient format because it stays close to the medium that you're writing in, lets you iterate quickly and change things around if you want to change how your chapters are organized and stuff like that. Is everybody, or maybe some, I don't know what the tools of choice are here, but Zurb Foundation is a popular front-end framework similar to Bootstrap. And Zurb uses Assemble to build all of their documentation. This Zurb is, I think, according to GitHub stats anyway, is the second largest front-end framework in the world right now. And all of this documentation is built by Assemble. And before I dive back into my stuff, I'll just show you a little example of how they're using it. So they're using what I would call the current version of Assemble, by the way. And we're here. What I'm going to be talking about today is the next version, what we're actually in the process of releasing now, v06. This is an older version that's just based on Grunt build tool, but this is the entire configuration that's used by Zurb to build all of their documentation is right here between these 20 or so lines. And all of the documentation is split into these folders, into concepts. I mean, instead of speaking to the actual folders here, really it's just broken up into partials of things that are reusable. So for their sidebar and their actual UI elements, they're taking things like alerts and buttons and things like that and making those into includes. And then they have data files that has some data that's reusable in certain places. And they have layouts that wrap their pages. And layouts generally consist of the head and footer of an HTML file or a page. And everything in between that is a page. So in any case, it makes building a very large site actually really easy. And we have a few users that say they build 16, 15,000 page sites with Assemble. So and there's also a company called Optimizely that does multivariate A/B testing on websites. And their service, what they sell is A/B testing to help you do rapid prototyping and things like that, to help you figure out what's effective on your website. Is the green button effective or is the red button effective? And should it be on the left or the right? And should it say click me or something else, And they use Assemble to build their own website. So it speaks to, I think that is, in my opinion, that's the coolest testimonial to how fast Assemble makes you at iterations, is an A/B testing company is using us. It is using Assemble. And Optimizely is founded by the folks that did the fundraising for the last Obama campaign, actually. I don't have any opinions on that. So now I'm going to switch gears and kind of talk about, I guess through the rest of this, I'm going to talk about how to actually create an Assemble project. But I'm going to leave a bunch of time for questions and just discussion to make sure that I'm actually addressing things that people are interested in. So during this creating a project part, I'm just going to keep it real real basic. We're not going to get into too many real advanced features, but I'm happy to answer questions about those things after I get through this if anybody wants to know about more advanced things. So to start a project from scratch in a Node.js environment, the easiest way to do it is to use generator assemble. So you would do, I didn't put this on here, you would do npm install generator assemble. And if you're familiar with Yeoman, I mean, you basically do yo assemble and it builds your project. But that's not what we're covering today. I'm going to show you how to actually build one from scratch. So to install assemble, if you're familiar with Grunt or Gulp or other build systems out there, and we actually use Grunt and Gulp extensively in our projects, you install assemble globally first so that you can take advantage of the CLI. So to do that right now, since we haven't officially released this on NPM yet, you would do npm install global and then just assemble, which points to the GitHub repo. And you have to make sure you put the correct branch afterwards. So you have to do # and then v060. And then when you so now you start up a new project, and I'm going to actually show you some code here. But in each project that you do, you have to install, just like you would with Gulp, you have to install assemble for that project so that you're always keeping versions close to the project. It could be a disaster if if you bump something globally and it's not compatible with what you're doing in a project. So that's the first thing when you actually start a project. And then just to run assemble, it's just assemble in the command line. Okay. So creating an actual assemble file. Does anybody here use Gulp or similar build tools by any chance? A few? Okay. So assemble is a build system that's actually based on some of the conventions of Gulp. We don't use Gulp, but we use some of the same libraries as Gulp. So the main element of an assemble file is a task. So the first thing you do is you create a task, which is like a wrapper around the things that you want to do. And you have to name it. Here we're naming it default. And inside this wrapper, we're going to tell it where our source files are and where we want those to end up after we build. So let me flip over into some real code and show you an assemble file. So at its most basic, an assemble task consists of a source with whatever source files it is you're trying to build. Generally, the main files in our projects are some kind of template, so either HTML or handlebars or something Lodash related, and whatever your destination is. And in between the source and the dest, we can add as many plugins as we want by piping them through. So for instance, we have a prettify task that formats HTML. And actually, this would be done after your templates would be rendered, but I'm going to throw it in here anyway. So this is just to give you a sneak peek at what I'm going to be going through. This is where your plugins go, in between your source and your dest. What we're going to build here, at least walk through a little bit, is how you would take something very simple like alerts or buttons and turn this into a reusable component that ends up as, eventually, with a lot of work, turns into something like what you see with Zerb's documentation, the foundation documentation, or even a lot of folks use Symbol with Bootstrap. Say you have alerts or buttons that look like any other HTML component. Might just convert it into a template. Here I'm using handlebars as the example by taking the text that we have here in our class, or rather we have our class and we have some generic text thrown in there. We're just going to rip those out and throw in some templates. And we're just going to keep it simple here. And now, basically, so what I'm going to do is, just so I can explain what's happening here, because this is kind of what the magic of assemble is, I think, part of it anyway, is assemble by default will take template files, like alert.hbs, let's say, and then take data files, like what we can create here, like alert.json, and then when you define, you just tell Assemble where to find those files, and Assemble will match up the data with the templates automatically. So here in our example, since I created a file called alert.hbs, I'm creating a data file called alert.json. And now all we have to do is tell Assemble where to find the data file. Here, obviously, you wouldn't just define one data file in your config, but here I'm just defining alert.json in the data method. And then when you could do it this way too, just feed the data directly to the method as an object. And then when we run Assemble in the command line, Assemble automatically puts the template together with the data and spits it out, whatever depth you defined in your Assemble file. If you want to make it more dynamic, here's something that I think, to me, makes Assemble extremely powerful, and it's just one feature. It's called Namespace. And what we're doing is, if you're familiar with the Node.js path module, basically as a first value, first argument, you just pass in base name or dir name, essentially a variable that you want to use to dynamically name the data files. So let's say you have a folder full of, or you have a file called alerts.json. Instead of just reading in alerts.json and taking whatever that data is and feeding it to templates, what Namespace is doing is it's taking the base name of the file and using that as the object key to make it a lot easier for you to create dynamic data to be passed to your template. So you could have a directory full of different files, and each one, the base name of the file will turn into the object key that's passed to the templates. Does that make sense? Okay. So moving on from partials and simple components, to create a page, let's start out with something like just a simple HTML file and how we would define that in our Assemble config. Just have a simple file. This is something that I think newcomers to Assemble struggle with a little bit, is when you build a project, think of the main pages that you're building, or the things that are seen by a visitor as your pages. Those things go through the pipeline directly, meaning that you're defining your pages in your source. So your about page, your docs page, your index, whatever the main pages are that are being seen by users, those will ultimately go through your source. If you have partials, you have layouts, you have things like that, we're not defining those in the source. I'm going to show you how you define those over the next few pages. So we created an alert partial a few minutes ago. To add partials to your project, you use assemble.partials, and you can feed it a glob pattern or a file path or an array of glob patterns. And then in your documents, you just specify the name of the files that you want to reference, and Assemble automatically finds those and matches them up. For a layout, you do the same exact thing. You just use assemble.layouts. You create a layout, throw a body tag where you want your content to go. And to use your layout in a page, you just define the name of the layout that you want to use. Here I'm doing it in YAML front matter. Assemble finds the layout called default.hbs, and it automatically wraps this page with that layout. It's really that simple. So I'm going to hop over, and now, I wanted to spend the bulk of this time actually running through it and showing you how it works. And the example I'm going to use to show you is actually the presentation that I'm giving right now. So Assemble is actually built the HTML files that I just went through. To do that, I have a task set up called deck, and it's just pointing to a templates directory with my HTML files. I'm using the extension .hbs because that's handlebars, and that's the template engine that I'm choosing to use here. And that's the template engine that Assemble uses by default, but you can use any template engine that you want to. So really, right now, I'm only using one file, one index file. And that index file has a series of, really, I'm using a helper called slide, but it's just like partials. This file has all of the slides that I'm using, and each one is pulled in dynamically. And I'll show you what those look like. Each file is just a simple markdown file. And as each one is pulled in, it's just converted to HTML and rendered with everything else. And then here we have, so we have this main task first that just runs through and builds the HTML. Very simple. We have a follow-up task called styles. And right now it's really only building one small less file, but it's just using a gulp plugin, actually. It's using gulp less. Assemble can run any gulp plugin. So all it's doing is building the less file for the deck. After that, I run a prettify task over it and format all of the HTML, and we're done. So those are the basics. But what if you want to do something more? If you want to do something that's a little more interesting, and say you have a project where you have dot files, you have templates, you have style sheets, you have all of these things, and you need to get them built dynamically, and you don't want to end up with like this massive project where you're having to basically build everything from scratch every time. You want to have reusable components, right? How many people here are familiar with Express? Bunch of folks, okay. So Assemble v6 can use, is very Express-like in that you can use any consolidate engine with Assemble. And to do it, you define the engine exactly the same way you do it with Express. So if you want to use different engines, and you can use as many as you want, you just do assemble.engine, whatever engine name you use, and here I'm using MD, specifies the file extension that will be processed with the engine that you're about to define. So for instance, I'm making up a fictitious engine here so that I don't have to put consolidate in. But so you could define a few different files, a few different engines rather, each of which that specifies a different type of file or template. So I have here a Markdown engine and a Handlebars engine. I don't have to do anything else in my configuration. Assemble will automatically use the Markdown engine on Markdown files, the Handlebars engine on the Handlebars files. I don't have to do any other, gulp plugin setup or anything like that in the actual source or destination down here. Automatically, Assemble knows how to use those engines on the correct files. So, for instance, if you could use a less engine, which we're going to be releasing. It doesn't matter what kind of file it is. It doesn't have to be templates. It could be for dot files. It could be for processing style sheets or whatever it is that you need to process. You can also define parsers. Parsers work the same way as engines. Whatever extension you define for the parser, Assemble will run a parser or stack of parsers against that file extension. So for example, you could have a parser that does Markdown to HTML conversion up front before any of the engines actually iterate over files or process templates, for instance. You may want to read in YAML front matter and do something to that data. I almost did this today, but decided it was too risky. But you can have a parser split up files, for instance, split up one file into multiple files for slides or something like that. and then have the next parser iterate over each of those files and do something else to it, and then pass those files on to the engines to process them. To do this is extremely simple with assemble. A parser is just a function that just takes content and returns it. So by essentially defining the parsers by using assemble.parser, you can define as many parsers as you want in your configuration. Just associate those with a file extension, and assemble will run those parsers over every file that has that extension. And I mean, that's assemble. That's the gist of it. Beyond this, there are some really advanced features that I hesitate to get into because you'd have to have some knowledge of assemble. But assemble also does routes. So you can use regular expressions or glob patterns to filter out files, for instance, in a configuration. And so by defining a regular expression for markdown files, you can create middlewares that only run over markdown files that match a route. Or you can create routes for, you can actually even create routes for style sheets. So you could, which is a little different than Express, but you could create routes for, we're using them for themes. So taking certain common less files or stylus or whatever preprocessor you use, you can create routes to dynamically build themes. And I was told to basically kind of spend a little bit of time going over assemble and spend a lot of time on question answer kind of stuff. So I'm going to leave it here and just do Q&A and see if anybody has any questions.
So how does it work to create a site like this first individual was asking?
Okay. Okay. So the vast majority of our questions are usually about how do I even use this? How do I even spin it up and start running it? So what we'll do here, and I know this is live, but it's going to work. So we'll create a new project here. I'll show you exactly how it works. Just narrow everything down to this one task. If you only have one task, you can just call it default. Assemble, by convention, allows you to define tasks by using this configuration here, where you can specify the name of the task. It's going to call it a task group that you want to run. And then you pass an array of tasks that you want to run. But since we're only running one task here, I'm just going to call it default, and Assemble will run this. So here I'm just defining a source and a dest. I'm going to take layout out here, and we'll save that for a moment. And let's just create a new HTML page. And first, I'm not going to put any kind of, I'm just going to make it a regular HTML page. Content here, and we'll call this docs.hps. My screen is a lot smaller here than it is normally, so it's resized, so it's a little bit. Okay, so now I'm just going to define the name of the file that we just created. Run assemble. Let me delete these other dest files so we can just narrow this down to the one that we just created. Run it again. So obviously we have out the other end what we just created. So let's make it more interesting. Let's turn this into an actual template. First we'll just do it with something simple like a title. I'll call it deck title. Now we can provide this deck information in a couple different ways. We can create a JSON file, or YAML file, and we can call it deck.json or something like that and stick some data in there. I'm going to keep it simple and put the data directly in the assemble file. I'm going to use the assemble data method. add a deck property. Title, slide deck, because I'm feeling creative. Run assemble. Ha. Brian, shout out if you notice something. Yeah, let's try it just directly. We're still in beta here, so. These things are okay. Now, I'm missing something simple. Our engine. Let's do this. Switch gears for a moment. Come back to it. We'll see if our partials are working, and that'll tell us, that'll give us better information about what I'm doing wrong here. Sometimes, I mean, well, we'll find out. Sometimes it's, I mean, it's useful for me to watch people sometimes figure things out. So hopefully this is useful to other people who are watching this. So. We'll turn this. Let's do this first. I'm going to turn this page. I'm going to turn this into a layout, actually. And again, a layout is just something that that wraps pages. So we have a layout called docs. I'm going to go back to my page, get rid of that information there, and we'll just create some YAML front matter and declare docs as the layout that we want to use. And just put some placeholder content here. And I should probably change the name of this just in case. Get creative, call it home. Oh, yeah, I know. It's trying to build everything, and it doesn't have everything defined. Thank you, Brian. So now, yeah, it's not wrapping. Well, there goes it for our live presentation, yeah. What's that? Yeah. Yeah, generally here, we're going to back up a little bit. I need to get my fictitious engines out of here. Okay. Thank you. Okay. So I backed up a little bit. Thanks for hanging in there with me. Okay. Yeah, but, yeah, data wasn't working for some reason. Oh, I didn't define the layout. Yeah, is that what you were saying? Yeah, of course. Okay, so backing up. We're going to try this one more time here, folks. And once I can get this going, it gets real super easy to work with. But we're trying to limit the API changes right now because most of it's locked in. I mean, the vast majority of the API changes are locked in. We have hundreds of unit tests. We hesitate to release it because there are still some bugs to work out, as you can see. Okay, we have home defined, and our layout was called docs. Shout out if I'm missing something, please. Thank you. It doesn't help me that I actually helped do the code for this. Okay, so we just define our path to the layouts directory, which is in source, not just templates, right? Let's try this again. It helps you out, lets you know if you're not doing something right. So default is not in your assemble file is what it said, which meant that I didn't have the task actually defined. So I had to go back in and correct the name of the task. So I corrected that. So now we should be building, and we have our layout now. So now let's try going back and adding some actual content, some dynamic content. We'll add just a button partial placeholder, and I'm going to go create a button now. We'll just add that to our includes, or wherever you keep them in partials directory or whatever makes sense for you. And now, so I don't repeat the same mistake a minute ago that I did with layouts, you go back into your assemble file and just create a partials, use the partials method, define the path to the includes directory, Thank you. Trying to figure out how to resize my screen here, but I don't see it. Did I save it somewhere else? I must have. Let's try that again. Okay, now we're going. Well, this is not going as we hoped. So, I mean, it's like working all day without a single hitch. And then, I mean, not one. It was like, this is great. Everything's working completely. And I think it's just user error right now. Do you see anything obviously wrong that I'm doing? You want to step up here too? And yeah, no problem. You just might catch something that I'm missing. Oh, was I looking at the wrong file? All right. That's why I should clear this thing out again. So it was working. I was just looking at the wrong destination file. See, I mean, I'm not exaggerating when I say my font is like 7, 6. Okay, so now we have our button. We have a button. Real exciting, right? And our button is just using some static data that we have hard-coded into it. Let's put some dynamic data in the button and hope it works. I'll use some generic things like modifier and text. And then now we'll add some data. Do I need to find it? Yeah, that's what I thought. Okay. So now it's starting to work. So we have a button, real exciting stuff. We have a button building with dynamic data. But the interesting thing about this is it's something that configuration-wise, for designers, is real easy to learn and pick up and gets you using a workflow that's more usable by the back end than just handing off static HTML. So from here, we can, and by the way, I'm a designer, so I'm not ragging on designers at all. That's Brian is actually has been the programmer for most of the duration of Assemble, and he's letting me learn and take over some of the credit for the programming side. But so now to like a dynamic list, okay. So to build like a list of buttons, I think something more interesting would, let's do that here. What's that? Okay. You want to do an each, or do you want to do something else? Do you want to? Yeah, that's fine. So I'm just going to create a JSON file, and do we have a directory for this already? Data here. Is there a problem with this format? Actually, we don't need to do that. Do an array. Oh, yeah. Yeah, you're right. I know it's so exciting watching somebody type. But so now I'm just gonna stub in some different classes so you can just see how, once you get your own workflow down, you can see how easy this really is to do. And did we set this up so that it would read that data file? Okay. File name. Oh, do I really? I can't even read this, Brian. Thank you so much. Okay. And now we have to go into our assemble file, and we have to actually set up the data. We can use the data property to do the data, but should we just use namespace for this? Okay. So here, the namespace method that I described earlier, we're going to use that now. And I'm going to use base name, because that's going to take the base name of the actual data file that we're going to read in, and it's going to turn that into the object key. I'll comment that out for now. No. Thank you. We have one button rendering. Yeah, you know something? Say again? Button is saved as .json. You know, we might not have this part of the API fleshed out yet, but. Well, so the way it's supposed to work is it's supposed to build a list of buttons out. This is, you know, if we did this with the current version of Assemble, all this stuff is easy, but we didn't want to talk about the current version of Assemble. We wanted to talk about what was next. Did I use a plural in the? No. Yeah, go ahead. It depends on how it was defined in the file, which I think was, yeah, that might be a good idea, Brian. Which I think I defined it as a singular form everywhere that I saw anyway. So a lot of this is really just basically comes down to, how did you get that working? Yeah.
So the file, reading it in, if it's an array, it doesn't assign it properly to the data. So I just wrapped it with a regular JSON object and then had the array and there's data to be able to do that. So it's still some things to work out with namespace. And, you know,
yeah. In any case, so there are. Were you going to say something? I'm sorry. I thought I heard a question. So there are still some kinks to work out in 06, but these are really, really exciting features because of how quickly, at least when we, you know, in a non-live mode, they make things fast. The namespace feature in particular makes it really easy to take directories of files that are named in different ways and use the, for instance, you can create data files that are for creating themes. And you can use generic naming structures like, you can use things like button and index and things like that. And then in your configuration, just change the way that you're reading in the data to change how that data is passed over as context to your templates. Namespace, that method makes that extremely easy to do. Also, routes makes that really easy to do. I'd like to try a little bit more, but I don't want to. I don't want to risk it. But well, let's go with questions. Do you have any more questions about how to build certain features of it? And I can try to. I don't care if it's not. You know, we have glitches if I have to work through it. Sure.
On the earlier example that you had, the big long assemble.js file, the original one, you were listing on your assemble.layouts, your assemble.partials, you were loading up Handlebar files and Markdown files at the same time.
Mm-hmm.
In your individual tasks, when you're sourcing your tasks, can you do the same thing? Can you source from Handlebar files and Markdown files at the same time?
Absolutely.
Or can you do two separate assemble tasks?
It can be one. It depends on how you want to do your configuration. So I'll give you some examples. If you could, for instance, and I'm just going to throw out a scenario. It could be hairy, but you could just use the globstar pattern and define everything in the kitchen sink, right? Like this. Not HBS, MD, anything, just everything in the kitchen sink. Now you're leaving it up to the engines that you have defined in parsers. By default, Assemble is currently only going to recognize HTML, Markdown, and handlebars. HBS, MD, and HTML. Everything else either just gets passed through the stream or runs through a no-op engine, which doesn't do anything. So if you want each of those, like say you have 5 or 6 different file types that are running through, and each one needs something different done to it, and you want it to be run through the same pipeline so you don't have to create a bunch of different task configurations, you can set up engines. And we already have a ton of engines. I mean, in fact, you can use any consolidate engine, and you can also use any transformer engine. Transformer is a lot like consolidate, but it also has less and SAS and go ahead. You have a question?
When you do the multiple engines and multiple parsers, are they processed in order that they're added, or is there another way to determine priority?
Kind of yes and no. Okay, so they're processed in the order in which they're read in. So meaning that when we use VinylFS and Globstream and the same libraries that Gulp uses, so files stream through one at a time through the actual task. And this is something Brian speaks to better because this is his strength. I'll let you.
Well, for the engines, it's only going to use one engine, whatever one that extension.
Do you want to come up closer so you're by the mic?
For the parsers, it'll do in the order that the parser is added for that extension. So if you have .hbs and 5 different parsers, then it'll do the ones in order that way.
And so a lot of this is new. So the best example I can give for how parsers and engines work together is that when files are loaded and read, parsers kick in. So as it's being read in, you can parse. And as it's on its way out, you use an engine. So source, parse, dest, engine, if that makes sense. So, and the neat thing about parsers, again, is that you can run a whole stack of parsers against each file, whereas engines, think of it as just one engine per file. You have a less file, that might go through a less engine. But parsers can do anything. And I have actually certain tasks that I run that have five parsers that run over files before they get to an engine. So, and then routing is also a really exciting feature, and it works, again, we're using Express routing. So if you're familiar with Express and you have middlewares that you've used and they lend themselves well to static, you can use those same types of middlewares with Assemble. But we use middlewares a little bit differently, actually, than you would use with Express for the most part. The way we're using middlewares and the way we're using routes is we're using routes to filter files out. So I think of the pipeline as being like vertical. Like everything runs top to bottom like a pipe. So your files go through one at a time, and then routes give you a way to process things kind of horizontally. You can catch a file as it's going through, filter it out, run it through a stack of middlewares like you would parsers, and then bring it back into the stream and run it through an engine. And again, the nice thing about that is that you can have middlewares that are reusable, composable with other middlewares, and just set up a configuration one time and then reuse that on multiple projects. Something else actually I was doing earlier, and probably should have kept that way, but I was requiring in a lot of this configuration, not having to define it here. I was just requiring it in so that I didn't have to repeat a lot of it, and I was like, I'll throw it in here and try to do some of this while I'm here. That makes it easy to recreate workflows. Also, the same with templates. You can create templates. I have dozens of projects where I have just generic templates or generic data files for mocking. And we'll spin up a new project with a Yeoman generator, grab one of those node modules with generic templates, run assemble, build those templates, and copy them in. If they're going to be changed, copy them into the local project, and then start making changes to those templates. Some of the templates, though, are generic and reusable on everything that we do. Certain types of things that we use for information about our projects, related repos, and we have things that have data on, on links to get help on our projects and things like that. And that data is always the same. So we host that in one spot, and every project that we create, we pull that data in and just build it into the templates, and makes it a very easy process to spin up. Yeah. Say, yeah. Yes, absolutely. Did we use I think Parsers was something that we didn't see anybody else really doing this way. We did see an engine called Kerouac that we used as influence for some of this, but parsers are really just, I think we're using the vinyl file format as our guide with a lot of the components of Assemble. So your parser should take a file object that has a path property and a contents property, and it should spit that out the other end. Other than that, your parser is just a function that takes an object and returns an object. So, say again? Correct. Yeah, and I'm not going to run this, but say again. Yeah, we're not going to run this one, but just as an example, the first argument is file, and did we get rid of params, or did we keep that? Okay, so, well, we have an optional callback, I thought. So we'll just take callback out because you don't need it. But so the file extension tells Assemble which files to use the parser on. And inside this function, it's just JavaScript, nothing special. However, the file coming through, you should expect that to be a vinyl file. And a vinyl file is something that's used in the Gulp. It's used by Gulp. The Gulp folks created a convention, I guess a library called Vinyl and Vinyl FS. And all they're doing really is they're creating files from streams. And do you want to describe that a little bit before I describe how this works?
Well, yeah, so they just, they created the convention to use vinyl files, which is an object that they've got some properties on there. Contents is one of them, which could be like a buffer or a stream or something like that. And then they'll have path and I think relative.
They have some Node.js path module. Yeah.
But vinyl FS is just another library that reads in the files, and that's all its job is doing. It can take a log pattern, read in the files, and then pass them through the stream. And so we're just doing the same thing where we have the vinyl file that we're using, and we just added a lot more
processing.
More to the pipeline, I guess you'd say. So.
And to add some logical reasoning behind why we're using vinyl files, so it makes sense. In order for this to work, in order for any system to work well, there has to be some kind of standard or convention. And so we just want you to know what to expect coming into the pipeline, and if you're passing something out, there may be, whatever the consumer is, whether it's a plugin or whether it's a middleware or another parser or an engine, that common format, just make sure that everything goes through smoothly. We chose vinyl because it's well architected. It's so fast. It is screaming fast. Assemble spins up fast, from a cold start. But once you actually is another thing we just is difficult to cover here. But you can run watch mode with Assemble just like you can with Gulp. And once everything's already in memory, it's extremely fast for live reloading and things like that. And vinyl is a big reason why it's fast. So, yeah, okay, good idea. Am I actually reading any? Why don't we do HBS then? Well, I put my kitchen sink here, so. My eyes aren't so great. So here, I just did console, printed everything out to the console so you could see what a vinyl file looks like. Basically, it's just buffered content right now. So if you create a parser, really, the first thing you want to do when you operate on this, to do something to the string is you want to take the buffered content and turn it into just a UTF-8 string. So we're just going to do two string on it. print that out. And you can see we have our page content here, right? So anything you want to do to this is just regular JavaScript from here on out. Before you return it from the parser, though, you want to rebuffer the content to be kind to the next parser or whoever's taking over from here. So we would want to do and rebuffer that. And I'm not missing anything here. And then just pass it through. That's a parser. That's how simple they are. And the most common use cases that I have for parsers are doing things with markdown files where I have to do some kind of pre-processing to the markdown before it actually goes over to be processed by handlebars. I do things with front matter a lot. Here's something that I think, I'm not sure how most developers will react to this, but I use CoffeeScript in front matter instead of YAML. I actually use Coffee front. I'm not actually a big fan of CoffeeScript, but it lends itself really well to this format. So actually it functions in front matter because it can operate on the direct page that it's associated with, if that makes sense. And so in parsers, I use parsers to transform the pages coming in first, turn them into something before they actually go into the pipeline and get operated on by handlebars file or handlebars or Lodash or whatever engine I'm using.
I got a couple questions. First one is, can data come from other sources? A REST service or a database or something like that? Say you have a content pipeline where you have content creators putting a bunch of stuff in. You just want to get a static site out. Is there an easy way to do that other than having a mining process go to a file?
Do you want to speak to this? I mean, we were just talking about this on the way out. So.
Well, so like for data, because it's just a JavaScript file run on Node, you could go off to the service before the task runs, pull the data in, and then add it with assemble.data. But like for content, like for the actual page content, you could write a plugin similar to a Gulp plugin that would get that data and then inject the new pages into the stream as it's going through. So we've still got some more work on some utilities to be able to make it easier, but it's possible to get that from other sources. And it's also possible to write to other sources other than the destination, like to the file system. So you can override a lot of that to be able to.
Was that the next question? Okay.
But yeah, so like I had this running where in dev mode or design mode, it builds the static pages, but then we've got an express server running and it uses assemble to do the rendering. So it pushes the result out to the response stream, so you still can get live static pages.
Dynamic static pages. So I guess the takeaway there is like assemble source and assemble dest. Assemble source is, I mean, this is a good question because all it is one way of reading in source files. But you could actually extend assemble by creating another method that's, assemble foo, whatever it is, to read that data in and feed it into the pipeline. We'd actually talked about creating another method in addition to assemble dest called assemble.deploy. So instead of actually writing to the file system, it would deploy to GitHub, for instance. It's actually, it wouldn't be complicated to do. It's just the most time-consuming thing about the project is always documentation, actually documenting things and doing the unit tests and publishing. But did you had another?
Yeah, he actually got my one question, but my other question was, as far as backward compatibility, did anything get deprecated, or could I go to a 0.5.0 and pull it all into this?
That's another very good question. So one of our goals with this version was to remain backward compatible, and that was a challenge. But here I'm going to mock out something that you can do that we will be publishing in transition guides and things like that here soon. I already have some things worked up for this. But in addition to passing, in a configuration, you can pass source options on the source property here. And you say, for instance, a good example here is on the desk defining an extension. And I think that's a good example because while we were working on the presentation, I was generating both HTML and Markdown files. So I had two different tasks here where one of them had the extension as HTML and one is Markdown. One was generating Markdown notes, the other HTML files. Well, you can also define all of these options. If they're generic and they're not specific to source or dest, you can define them on assemble.option. And this can take a key value pair or an object. The point is that the reason I created it this way, this particular method this way, I have hundreds of projects, literally using hundreds of projects using Grunt. And I'm still a fan of Grunt, but I'm actually able to take the configuration, the config for my Grunt projects and stick it right in assemble options. And it gets read in. It pretty much works. There's a little bit of tweaking that needs to be done sometimes. Beyond that, the more important thing is API and how you're actually defining data, how you actually create templates. Virtually everything that you've done with prior versions of Assemble should work in this version. I don't think there's nothing I can think of in terms of how data needs to be defined or things like that that's actually going to break. And we're even trying to make it easy to transition configurations.
And we'll be, so Assemble was originally a Grunt plugin.
A Grunt
we're
task.
changing it to be Grunt Assemble, and it'll also have the same configuration, just run with the newer version of Assemble. So if you have your Grunt task, you can still do that. I think the layout, the bottom tab.
So if you already are familiar with Assemble, there is one thing that will break. And this was something that we didn't want to break it initially. We tried to find ways around it. Ultimately, this turned out to be the best decision, and it's also, in my opinion, a really exciting feature about Assemble. We use a library called Layouts. Layouts, I mean, it's a separate library, but basically what Layouts does is it builds a layout stack. You feed it. It's what allows you to create a page that defines a layout in the front matter or in the configuration, and it just finds that file and wraps it around the given file. And those can be nested as deeply as you want. There's a library called Layouts that does that. It can be used with any JavaScript library. Well, the point is that in order to use Layouts and let it build stacks without corrupting templates from X template library, meaning Assemble can be used with any library, not just handlebars. I mean, any engine. So you can use it with Lodash or whatever. Whatever delimiters that you want to use, this layout stack should be able to be built without messing your templates up. And this was a rabbit hole that we went down. We realized you can't just build your layout stacks and then with the same engine that you're building your pages with. It just doesn't work because it keeps trying to render the templates as it's looping, if that makes sense. So we had to basically separate the template engines. And so layout stack is built with Lodash, and it's extremely fast. And by passing delimiters, generally you would do this on your, you'd do it on your options here, but you can do, say again. So if you need to change the delimiters for layouts, you just define them right here. Whatever your crazy syntax is that you want to use for layouts, you would define them right here. You would define it on, you can actually define different delimiters for every engine if you want to. But this was our way of making it as foolproof as we could to allow you to build layout stacks and not experience issues when you're actually rendering your pages. But so that would break your stuff if you were using prior versions of Assemble. You'll have to start using the default syntax that we're using now is this. Primarily because we're using handlebars and we didn't want it to be, conflict with that. So you had another question?
Is there any way to tell different pages to use Assemble.io instead of the one that you
So render it with assemble instead of Jekyll, basically. Well, I wish it was automated like that, but really, I mean, you would have to build your pages with assemble first and then just push them up to GH pages. And there are a number of tasks out there for Grunt and Gulp, different tool chains that will take whatever you're building and as just one of the build steps or even defined in a task, let you build the site and have it automatically deployed to GitHub. Another practice that we follow is you can actually you can create, just like gitignore, you can do, is it no Jekyll? Yeah, it's just, you can do .no Jekyll, and it tells Jekyll not to try to render your pages. That doesn't really, solve what you were asking, but
I've done some stuff with Travis CI and CodeShift, like some continuous integration or continuous deployment systems where, because you can run assemble on that, and if it passes, then have a script push it up to GH pages.
we would love to get the community, some folks in the community to help us do some deploy tools. And I think we will eventually come out with some deployment packages or methods, depending on what we need. But
One last question. Is this part of a business model or is this an open source product that your company puts? How's it been?
it's completely open source. So it originally just started to solve a bottleneck in our workflow process. Brian and I actually recently got venture funding for a startup that we have. And as we were trying to create the prototype to get funding, we just found, I'm not going to go into that concept, but it's a B2B concept. It's more complicated than your average B2B technology startup. And we knew we had to build something fairly aggressive, so we wanted to have tools that made it faster and easier. And that's why we built it, but it's 100% open source, and it always will be.
Is there going to be any type of services around it planned, or is it really just more support for something?
We've had a lot of questions about that, and we've brought it up to our board a couple times, and it's interesting. But there are no plans to do it currently, but I guess it always depends on the case, and it depends on how related it is to our core business or Assemble. So if there were support requests and the support requests had to do with just helping to implement something with Assemble and it tied in directly with something we had to accomplish anyway, I think we would consider that. But anything else would probably be a distraction from our core focus. Yeah, no, thank you. Any other questions? All right. I think that's it for us. Well, thanks for bearing with me through the difficult process of getting our beta software running. So I really appreciate it. I've been on your side, and I know it's hard sometimes. So thank you.